Is about challenges, and a lot of people ask me questions since yesterday, a lot of great questions, and they're all related towards, hey, tell me one holy grail solution to solve all my problems. And one of the things which you have to look at is, and I gave them a simple answer saying that depends upon your use case, what you're trying to solve. So one of the things I'm going to ask ourselves is, what's the problem we are trying to solve? That's where I'm going to focus mainly of my time is. So next 60 minutes, we're going to look at each one of those architectural challenges and see what is available in the market currently, what's the best practice. As you know, Neil just said that best practice 10 years ago is an anti-pattern now. And whatever I'm going to speak now will be changed, and it will be changing. It's part of what we want to do here. So my Twitter tag is rbharadwaj1, and you can ask me any questions there. If there are questions, I'll answer them through Twitter. So we'll be able to answer and collaborate using that. All right, so what we're going to talk about is the challenges. What are the different challenges in the cloud is? What are the design principles which are there? I'm going to ask questions to you guys, like, hey, do you have this problem? How do you solve this problem? That's the way I'm going to look at it. We look at the resiliency, and we look at what kind of databases you should pick. We will also look at threat modeling tools which are there. How do you make sure if there is a problem, how to solve that? And at the end, we'll look at real-time services. So it's a jam-packed questions and your interactive session. If you have any questions, send a tweet to, and I'll answer it as soon as possible. All right, so number one problem which we all have is our product owners comes and says, we want it 100% availability. So this one is for, most of the company, they provide like 99.9% availability at a given time. So that means total 5 hours per month of unavailable time. So how are you going to achieve that? That's one of the challenges which we need to resolve. So during the course of a year, you can see here, it's 52 minutes only, which is a tall order to meet. Another problem is, what's your response time? And people ask me a question like, hey, how can I build my API which has a better response time? We'll talk about that. What can you do? If you have a variable load, what can you do? If you have a constant load, what can you do? If you have an unexpected load, how are you going to handle this situation? I mean, we all have the same problem. I agree with that. You're providing an API, you're testing that API using 100 users, but some other person is using it for 10,000 users, and there it crashes. And a lot of the programming model, they crash because of this reason. So another thing we want to look at is the whole cycle of ISO 9126. I would like you to go and check it out yourself, and the main thing, if you look at this model, if you see, is you want to start from reliability. And we'll cover all these aspects today, but reliability, how adaptable you are to the change. If you have a problem, how maintainable are you? Now, I'm talking about a distributed application, asynchronous distributed application. If there is a problem anywhere, how do you debug that problem? How do you do that? Currently, how are you doing that? I know we have faced, in our company also, we have spent like 2 days trying to find out what the heck is going on, where is the problem? There's a P0 issue you have to resolve. So there's no way of traceability. So we'll talk about how to achieve that. We'll also look at from the usability perspective, how understandable it is, how people are able to use your code or your UI. So change from your brain. From now onwards, that whatever UI you are building, that is the UI people are going to use. Just forget it. So the way you have to think is API first strategy. That means you need to first build the APIs and then the UI, because your customers will build their own UIs. Think about it that way. So never build a UI which does not have a support for the API. Otherwise, you're going to face a lot of problems. And then, of course, security is also part of this. So as we know that supporting any kind of problem which you have got, it has a right solution. And it means that if I have a small nail, I need a small way of handling it. If I have a big nail, I need, a hammer or some other way of, solving that particular problem. And crash test your application. How many here does this thing? This is something, which we don't do that often. But, hey, you have servers running. You crash test just like exactly the same thing as the cars. When they do the rating for the cars, they are all doing crash testing for it. Go to your application and plug out the servers. I did the same thing. I had a Kubernetes application. From the Kubernetes app, I knew what IP addresses I had. I deleted those IP addresses. I said, hey, what happened? Let's see. I had 4 of them. I deleted 3. See what happens. Am I going to application totally going to collapse? Or how it's going to react? So it took like 5 seconds for the other servers to come up. But we should test these things. That's really important. So that's really important. The other thing is vendor lock-in. You're building some tool for yourself. You should be not vendor locked in. Use open source technologies. Not only just use open source technologies, but open source technologies which has the enterprise level support also. You need to use that. And also use the right kind of plug. Or use a universal plug. How about use a universal plug? So that means you build your application from scratch, which is extensible. So you are utilizing the similar business models. So you think that your company is alone. But you know what? The most important thing is, and I will talk about Uber in a second, but what they have done is they have interfaced with other applications. Now, you are not writing the code. Facebook has done the same thing. Facebook has created open Facebook APIs. Other people are integrating on top of it. Same thing Uber has done. So if you want to go for any trip, you can just ask Alaska. It will book it for you. Same thing is true for all the other TripAdvisor. They actually interface with it. So you think about which companies can interface with you and provide that guidance and remove the vendor lock-in. Next is extensibility. How extensible my application is. It's going to work now, but the components needs to be parallelized. There used to be a model where we used to have reusable component. Let's have a reusable component. Duplicate code is fine. Duplicate code is fine. Duplicate data is perfectly fine if it's satisfying the use case for performance. Our performance use case is what? Less than 500 milliseconds. So think in those terms and create the components which are independent. Not just like JDK 1.5 where they had 226 different packages all intertwined to each other. So if you want to make a small change, the whole gigantic thing has to change. So all those things you have to look at and try to resolve. Of course, reliability is important, where you're looking at mean time between failures, where you're looking at total time spent minus the sum of the downtime which is given to you and come up with the mean time between failures. And that's not the important thing. Important thing is the mean time to repair. So when you build your application, how fast your application can come back up if you lost the data. If you lost the data, if your partner lose the data, how fast can you come up? What are your availability zones? Where all it's available? So that's the key part which we are trying to ask here. And we are also looking at failure rates. We are finding it's kind of a hot tub, like wherever there is a new upgrade, there will be distability. But you want to minimize that distability with the automation perspective. Next is the scalability. So this is like a 5-minute overview, and then we'll go over each one of them separately as part of the principles. So scalable, you should be linearly scalable. If you have a replication factor of 3, this is a Cassandra server I got. If 2 server goes bad, still it's able to scale. So Netflix is using it, like 30% of the internet traffic, they're using it in this case. Now, when you're building your application, you are not alone. You are not in a silo microservices land. You are always always have performance issues because some other people have a bottleneck. Now, you are running at a perfect speed. You are responding in 500 milliseconds, but your partner is not. What is the pattern to use? That's the question I ask, and we'll talk about those patterns, how to solve it. And you should be resilient. What does resiliency means? that even if there is a flood, still your application should survive. You should be able to move forward with the particular application. Let's talk about Uber quickly. So they used to have a monolithic app, and this app used to have like kind of two trunks was there. One is the supporting of the actual servers, like you have interactive. Like you're asking for different cars. I want to go from one location to another location. Another is the backend service. They used to have one app providing both the solutions. So they faced the same thing where they were trying to create this monolithic app. They realized, hey, they can't scale this. So what do they need to do? They need to break that application into two different parts. They had to make sure that they find out what are their failure points in their application. And I'm going to tweet after this talk regarding my podcast, which will talk more in terms of like what should be your methodology of really creating the API first strategy. And there are two podcasts there. And then you can go over in more detail what I'm saying there. The whole idea here is that you want to find out those bottlenecks and provide the REST APIs to support it. It's not aftermath, like when it's going to fail. You have to provide it beforehand itself. Okay? Same thing is true with like, somebody asked me a question like, that I got an API which I want to work with, but that API is not responding. It's slow. It's not really slow. APIs are not slow. They are never slow. The problem is you don't have service limits. How many here have service limits in their APIs? That's the first thing you need to do in your API. You tell to your manager, hey, this is my service limit. I cannot perform better than this. You say that 10,000 points is the service limit I got. So what it really means that you have 10 customers, you can get data for 10 days. That's perfectly fine. You have 100 customers, you can get data for 10 days. Whatever it is, you have a multiply factor, and you should be able to provide that as a service limit. Now, you may ask, like, why that is important. I will talk about in the patterns, like, why that is the really good thing to do. Okay, so with that, what they were able to create thousands of services. That's the beauty about, they were able to build trip tracking, mapping, routing, all these algorithms they were able to build. And they were able to support 99.9% availability as a whole. Operation cost went down, so they were able to reduce their operation cost and less than 500 milliseconds response time, creating the domain model for themselves. So if I'm looking at your application either will be residing in the public cloud or private cloud or microservices. You have to deal with all three of them. So you need to know about all three, like how do you satisfy, if you have a challenge, how to satisfy that situation. And yeah, we talked about this one. That's where the API first strategy comes in. You want to build one API for the UI as well as the REST APIs. API as a product, that is the new norm. So that's been adopted by a lot of teams, and you building that way. And because you're building the APIs, you're exposing these APIs, and other business APIs are created on top of it, which is giving a better user experience to the APIs. API users. So this is a Twitter case like, hey, if you bring the server is down, what do you need to do? You have a scalability problem. Now we all have monolithic app, and Twitter had monolithic app at that time. That was like 2010-9 timeframe when it was having it. So whenever you have more followers, they need to expand. They could not expand, and a traditional solution didn't really work. So in that case, what they did was they actually removed that with availability, scalability, and self-healing processing. That's where the Netflix comes in. So when I say Netflix, what they're providing is that if one server goes down, this Cassandra server is going down, another server picks up, and you're in split second, that movie is still going on. So you're not losing a split second response time because there is a replication factor of 3. That's the main thing here. And that's the same way you need to build the microservices. You're building these microservices. Neil did touch on the microservices model where you're looking at different layers and providing the service which is more atomic service and be able to scale really fast using this service. And not only that, from the testability perspective, you want to do something like Chaos Gorilla. Chaos Gorilla means that whatever your server is, you have deployed in 2 different zones, remove one zone and see how fast that zone comes back up online. Back up online. That's really important. You're not losing any data from there. And they started doing that. It's really useful for them. And they had like different ways of doing it. This is called Simian Army. And they have something Doctor, which fixes unhealthy resources. They have something here called Look for Outliers, Conformity. Janitor, which cleans the unused resources. So you think about it, like you want to build your own this test strategy in place to really make this happen. Then comes the service discovery model, service discovery pattern. What I'm saying is that if we are using Zookeeper as a service, then the clients, because it has a leader here, and the clients can directly talk to the server and they get the response. All the services will flow from there. So that's the advantage of using the Zookeeper as a technology. And Netflix has Eureka. So I mean, you must have gone through some of the training on this. I wouldn't spend much time here. But the whole idea is to increase your throughput using it. That's where the resiliency comes in. You want to increase your resiliency for this model. So before I go ahead, what I want to do is I want to go through some interactive way of discussing these things instead of just talking about it. So let's go through some of the design principles, cloud patterns which are there. What happens if you have a periodic load? Well, how can you deal with this situation? So let's just go through this situation for a second. So in this case, how can a periodic peaking can take place? What you want to do is you want to scale up and scale down at the same time. This is called elastic scaling. And this can be achieved through either HA proxy, and this has been there for 5 years or so. So I hope we all are using this one for our case. But the interesting case is that what happens if you have unpredictable load? And that is the case for REST API, which I was talking about before. So how can a random unforeseen utilization be achieved? How to make sure that the workload is using them correctly? So what you need to do is you want to make sure that for any unplanned work, you want to create a proxy. So whenever the input is being coming in, you restrict that particular component. And you basically make sure that you go through this firewall to wait for micro batching. So let me talk about the micro batching for a second. So what happens is that if there is a continuously changing workload, that's another one which is a similar kind of situation as the previous one, where what you're doing is that for any input which is coming in, you're batching that input on this side. You can use Kafka. There's a SMAC stack which is available. From there, you can use actors and Kafka to really get that load, micro batch that load, and be able to process them faster. So that's one thing you can do here in this case. So what is the other issue which we all face? What happens that if you have elastic infrastructure? How to manage the elastic infrastructure? So to manage the elastic infrastructure, what you need to do is you need to look at the resource management, different resource management. Before we were monolithic app, we were having one app to solve all the problems. And we used to have one database, but not anymore. So now you think about your multi-tenant environment, it will have one monitoring tool for all the tenants. So think about you have one monitoring tool, and I'll talk about DCOS in a second, which you can use for monitoring and looking at these servers. But all these resource management across, those are all multi-tenant. So you have to make sure these are multi-tenant support is available for them. And pay as you go because you are making sure the servers are up and running all the time in this case. Now let's look at another use case where you are having you need to do a lot of processing. How to do a lot of processing? We all have the same problem, how can you scale out? You have large data set. How can you scale this thing out? This is the key value storage is there. You can get that storage, use Cassandra for storing this data. And key value storage, you can get the data from there and process it using Spark. Using Spark, and we'll talk about later on like how this can be done. But the whole idea is that this processing can be done in parallel. That's the whole idea behind it. When you can process this in parallel, it will bring back the results for you much faster. And that's where you can use Spark to do this particular activity. Now let's talk about another use case. And I think we all have similar kind of use cases. And now you have strict consistency. You want to make sure that you are absolutely consistent. Data is distributed, but it should be consistent. How are you going to do that? You can do that using Lambda architecture. Using Lambda architecture, what you can do is that you want to make sure that the consistency level here is 2. In that case, if you have 3 servers instead of these 2 servers, if the consistency level is 2, there are 2 replicas going in. Till the time you get an acknowledgement from both of them, you are not going back. That's the reading and writing operations for this one. Make sense? And now, not only that, you also have eventual consistency. How to achieve the eventual consistency model? Eventual consistency model that's the way which most of the people are doing it. So in this case, you want to write some data, you write it directly to Cassandra database, but eventually that data will become consistent. So this data might change, but if they have 3 servers, then it will first come to one server, then the other server will pick in. Why is this important? Anybody? Because eventually consistency really helps the big data. It's going to really help speed up your the response time. Response time will be the fastest response time using this model. So that's why we can use this eventual consistency. Now what could happen is that you want to send the data out, but you want only one method to be received. Do we have this requirement? Yeah. We also all wants to do that. So what happens in this case, that when you are sending the message queues through RabbitMQ or any other place, you filter that message, only send one message to the receiver. That's the key part here, because that's what we want to achieve in this case. At least one message is delivered. So this is kind of guaranteed message delivery you want to achieve. For guaranteed message delivery, you can say at least one delivery you want to do in this case. So what happens? How can a communication partners or message queue can be received reliably? So till the time acknowledgement is done, the sender will keep the results for you in this case. Now, same thing is true with the timeout strategy. So what happens in case of timeout? In case of timeout, when I'm writing some values, it is visible for the receiver to get it. When it sends the acknowledgement, you're not deleting that message right away. You're making that message invisible and then deleting it afterwards after the timeout is reached. So that's the way you want to take care of this particular problem. Now, you can also have, how about loose coupling? So you can have 2 different applications, totally different applications, how they are connecting to each other. So what you can do is, you can have loosely coupled applications where the advantage here is that this is mainly needed if you are having 2 different companies there. One is using .NET, another one is using Java, another one is using C++. How are you going to integrate with them? This is the only way you can integrate. What you're doing is you're sending the request from Apache Camel you can use for transformation. You're sending that request out. Because it's giving transformation independence, you can transform that message. And the time automacy is also there. What does time automacy means? Anyone? It means that if the other person is slow in receiving the messages, it's perfectly fine. That because you can wait for them to receive that particular message. That's the advantage we get here in this case. So what's the other problem which we all can face? Now there is sometime you want to make sure that application, somebody is calling your own application, which is how can an application component is accessed if direct access is hosting the restricted values. So you have some restricted components are there, or you have your own application. That application is storing all the values for you. Like for example, you have your application which is a monolithic app. You want to use proxy to connect to it, so later on you can change that application framework also in this case. So you can go over these, these models as we go along. But the main thing here is that you want to be resilient. So that's where circuit breaker is used for resiliency purpose, which basically gives you a fail strategy. What kind of strategy you can have? You can either fail silently or transparently in this case. So circuit breaker, what it provides is a way of finding out that, okay, what it looks like, the current load looks like, and also how many times it failed at a given time. So you can analyze that results later on and process them. Kind of you get a dashboard and you're processing that particular dashboard at the end. So we looked at some of these scenarios just now, and you can go over them later on this. Okay, so and then the important thing is that consider the communication between the application components. So when you are communicating, like New York to San Francisco, if you have components residing in two different locations, this has happened before also. Like you have these components available. It takes 70 milliseconds of one way. So round trip is like it takes a long time. So what you need to do is, if the services are dependent upon each other, interdependent services, you have to use a model something similar to Kubernetes. What they are doing is, in Kubernetes, what they do is they co-locate the services. Because they are co-locating the services, you can get all these services like in one place. That's the co-location model. Another one is reduce the number of network trips. Like when you are sending the values, like if you have a zip drive, you can zip. You can only ask for the thing which you are really interested in. So that's where it can be used. So Netflix did that in 2009. The bandwidth, when they were using it, they were making 9 trips to get the movie. What they did was they collapsed those 9, and then they were able to achieve much better performance by putting it in one request per call. So that's the reduction of the chattiness. I have seen 5 to 6 applications fail because of this reason. HTML5 callbacks are really good, but they are not really good for concurrent users. If you're having 50 concurrent users, it's going to fail. So that's something you have to make sure that you take into account as we do that. So another thing is choosing the right container technology. Like you can use Dockers by itself. How many are using Dockers? Okay. You can use Dockers by itself, but you can also use it with Kubernetes and Mesos along with them. So let's talk about quickly what 3 technologies will give us. What they will give us is, scalability aspect will be automatic. So Kubernetes provide this scalability aspect. So what they do is, let me show you quickly. So when I'm trying to scale, when I'm trying to scale, let's say if I started from here, because this is a service, I can scale it and make like four more services at the same time. When you do this scaling, what it's doing is this service will be provided by, this is service A. Whenever there is a call made, it will be made to this service. And the elasticity of the service is maintained by Kubernetes. So that's the beauty about their usage. So now what happens whenever there's a request being sent, you can increase or decrease that, or you can make it auto also, which and they'll take care of the maintenance of this model. Another problem which comes is the rolling updates. Like, when you have some changes which is coming in, and this happens with all of us. Like when we are building our application, this is the service model which I got. I got my four different service, like 4 different nodes which are available to me, and that's the same thing which Netflix does. Whenever Netflix has an update, they update to one case. So they update only that particular app. They added this app. They see if that app is working. And what you do is, the way you do that is, you have subsection of users. Let's say North Dakota, 5 people are watching the movie. They only watch that movie, and then if everything goes well, then you do the update. Basically make the other node also use the same particular API. But not only that, if there is a problem, you should be able to roll back. You see what I'm saying? So it's not just updating it, but you should have a rollback strategy also in place in this case where you can use them. So what it means is that they provide something called here service model, where this is the service being provided. Now within this service, you might have multiple co-located services within it, but nobody else is exposed to it. It's not like Java, where you expose a service, now everybody can use it. You can have limited use of that particular service. That's the beauty about this particular model as a whole. Now we know about the Dockers. So Dockers, what the Dockers really comes up with the 12-factor apps. So whenever we are building a new app, we want to make sure that our configuration management is not done as part of the server itself. We have to do the configuration management outside the server. So what it means that, so you can use the Docker image for a database to manage the configuration. You can also use Docker in big data and service discovery. So that's where Docker is pretty popular in all these terms. What really we are saying is that even right now, putting the monolithic app in Docker is the best practice. You may ask me, like, why do I put a monolithic app here? The reason for that is because it will be still performant. The server will be up and running and ready to go for all the requests which are coming to it. So that's the beauty about using that as a technology for you in this case. Another important thing is that if all these nodes which are available to them, you can have a personalized service also here. If this service fails, let's say the service fails, in that case, what you're going to do? How can you handle failure gracefully? Anyone? Put a default value. You should always have a failover strategy. You know what that means? That you should always have a way of, let's say in this situation, they have a personalized service. If the service is not available, what they're going to do? They're going to show whatever the movies which are currently available. That's the easier way of connecting and using it. We talked about Kubernetes just now. And same thing is true with Mesos. So what Mesos does is they have when the client have a request, they send it through Marathon, they send the request out to the Mesos master as a task. I want to perform this task. What does that task means? I want to perform a multi-operation for lots of big operation I want to perform here. So that's the task they're performing, and the executor basically executes that particular request. That's the advantage here. So it's an orchestration tool, which is actually much more powerful. What it means that if you have lots of technologies you are using, you can use this as one way of connecting it. For example, let me show you a quick demo of it, so you will understand how it's been used. So what I'm going to do is, I'm going to launch my DCOS, container right now. So it started that particular container. When I started that container, what it really doing is that I can install my CLI based on that particular container. So my DCOS is launched. Now what I can do is I can actually look at the dashboard. So let me look at the dashboard for a second. So this is the Kubernetes dashboard which is available to us. So what it's going to provide me is how many CPU resources are used, what's the memory usage is, and what's the failure rate looks like for my particular application. Not only that, you have been given different packages already integrated. So if you are using any of these packages, it's a very easy thing to install these particular packages as part of part of the usage. So if I go back again, let's see if it comes up. Okay, so I got this here. So what I can do is I can actually add, and in this case I'm going to add a service. I've got a Docker image. I'm going to add a Docker image. This is my Docker image I'm adding right now. And what I'm saying here is that this Docker image has one instance. I'm saying only one instance is available at a given time. So what I can do is I can say marathon, add this particular Docker image. So I'm adding the Docker image. And if I now list the marathon, I see one is available at this time. But what I can also do is I can curl. And when I'm doing a curl, it's actually reading that particular application and running that application at the end. I can look at the cluster, and it's saying 4% utilized. Okay? So if I go back here, it's saying it's 4% utilized in this case. Now, you can also look at the marathon and find out that application is running right now. So this is my application which is running. I can look at it, and it can also provide you a health check. A good way to health check that particular application. It's nice and easy to use that particular application as a whole. But not only that, you can create this marathon application by creating an application through UI also. And you can provide here what's the name of the Docker images, and that Docker image will be providing that particular support. So let me add that Docker image here. So it will do the same thing. It will create the JSON object which we had, and once this JSON object is created, you can say, hey, I want to scale this object or not scale this object. So that's the beauty about creating this particular app using this model. Okay? All right. So that said, so now we had talked through, but now these technologies are used by iPhone, and other people are using these technologies to decide what needs to be done there. Now let's look at from the cloud perspective the issues which comes in big data. So when I'm looking at a big data aspect of it, what it means that when I'm looking at booking a flight ticket, what happens when I'm booking a flight ticket? Well, we go in and then say that, give me the cheapest flight what I need to get. And it goes in and get all the flights for me. But it has to get all the flights really fast. How it can do that? It has to store all these values in Cassandra, or a database which is much more reliable and fast data is there. That's where you're putting all these values. So that means there is a possibility that your data is not consistent. When the data is not consistent, that means when you're asking for a flight, you may overbook that flight. United does that, and Delta does that a lot. And you might have heard few incidents just recently happened where a person was dragged out of the flight and got bruises there. So the same problem which is there. But what we are trying to say is that that's the model you have to go to if you want to be really responsive. So what that means that in your application, you should provide your application as eventually consistent application. So how are you going to support this? Using compensation pattern. So what is compensation pattern means? That means if many people have already booked the tickets, they are overbooked, then they pay $500 or 5,000 rupees extra to really compensate you for that particular transaction. But what that's giving the company is that availability. They are getting 99.9% available. So that's the beauty about this particular model. Now the big data as a whole, if you see, data can be at rest. When it is at rest, it can be terabytes of data. It's like a big database can be there. Data can be in motion. That means you want to transform the data. For example, from a sensor, if you are using IoT device, Internet of Things devices, you might want to transform that data. So for transforming that data, you can use data in motion. To use that, you can use Spark for processing that data. And data in variety. The whole idea here is that you want to give right information at right time to right person. And not only to the right person, but they should be able to process it faster. So that's the main thing. And automatically, they should be able to process that record and move forward with that. So there are 4 characteristics for it in big data. The number 1 characteristic is that data is not residing in one place. It's residing in multiple cores. That means when I query the data, it's actually being queried through multiple different partitions across the network. That's number 1. Number 2 is the computation of the data is done in memory. All the data is processed in memory. Number 3 is you're always inserting the data. So why we are only inserting data? Because inserting a data is the fastest operation. If I want to update a data, it's slow. So they always insert the data, and later on, they can remove the extra things which are not needed. Delete is also an insert in the database. And you store the data either in the columnar fashion or the row fashion. So both are possible. Key value pair are possible. By doing that, Facebook and other companies are able to utilize this and be able to process the data really fast. That's the same data being used by Internet of Things. Like all these data is being processed really fast using the same technologies. So what it means that let me show you quickly. So what's really happening is that we have the data being processed as a technology. So when I look at the statistics, the data is not coming only from one place. Data is coming from the car, from the bulb, all the home is connected to each other, and all these 7 billion devices are connected. And this is a great opportunity. Everyone got a cell phone right now. So you can reach all of them and to process this particular data fast. And to process them, you need to use Spark as a technology. And what are the innovations, what you can do? One of the things you can do is connected cars. So now, whenever there is a car connected, wherever you need to go, you can help each other. Like when I'm going from one place to another place, there are some Wage is one of the apps which is available. They tell wherever there are problems within the road, like people are interacting within that same app, and we know if there is a cop there and or other things to help us out moving along. Not only that, connected doctors. So doctors are now connected to the patients, but just by the gadget. So I'm wearing this gadget. My doctor knows already, what my blood pressure levels are and what I need to do. There is an insulin pump, which injected here, and you have to interact with it to tell, hey, how many carbohydrate you have taken. Accordingly, it will make a decision, looking at your pulse rate, looking at other details, how you're doing and everything else, how much insulin you need to take. So it's been automated, using that model. So you think about like different devices you can create, using this this particular model. So that's where the Spark comes in, and this is the #1 hype cycle. If you ask from the Gartner, this is at the top of their list. Like at the top of the list is the machine learning right now. So it actually started with key performance indicators. So when I say key performance indicators, what does it mean? It means that we used to do, and we all used to do, ETL process. How many here have done ETL process? Have ETL process currently running? It runs at night, and in the morning you get the results. Now how about you get the same results in 5 seconds? Analytics is near real time. That used to be 2 years before, that was the main thing which was there. But now that's what the key performance indicators are. These are all the things which are connected to each other. That actually feeds the machine learning. So what happened nowadays, Facebook and other companies, what they're doing is, and Uber, what they're doing is they're running their heuristics at the time wherever there's a less load there. So they're utilizing all their servers to the capacity. That's the beauty about this. So machine learning is all done as part of the Spark, so to help you gain insight of how the customer is behaving and using their particular system. To do that, ACID transaction, we know atomicity, consistency, isolation, and durability. Is it possible with big data? Anyone? It's really not possible. Why is it not possible? You may say that, hey, I have a replication. I have billions of rows are there in database. I have a replication. MySQL, SQL Server, Oracle, any database you take, you can have master and slave. There will always be a replication lag of few seconds. So you cannot call it ACID transaction anymore. That means the data is not consistent. So period, like, even if you want to use that as consistency, is not possible. So that's a problem, which you need to solve. You can't say it's a consistent framework. How many here took pride in writing SQL like this? I took pride in writing SQL like this. It's the inner join and outer join, and they're all joining each other. And pages and pages of these kind of SQLs. And I used to feel very happy about it. Like, I'm talking 12 years back, not right now. That creating this kind of SQL, what's the guarantee of this SQL executing for millions of rows? It's going to take more time. It's going to die. After some time, it's not going to even process. So that's where you need to think differently to solve this particular problem as a whole. And you may say, hey, we have database sharding there. There are tools which are available which can shard the data, and now you can process them. But if you ask for a query from 2 different servers, it still needs to process and combine and put in the results. It's still going to take time. So not really. It's not going to solve your real problem which is coming in from the database perspective. So that's where the base comes in, where basically it's available. It's in the soft state of mind, soft state, but it will become eventually consistent. That really helps in availability. That's the key part which I'm saying here. So if your product owner comes in and says that, hey, you must do highly available system, which is highly consistent and partition tolerant, you say that it's not possible because of this CAP theorem. Okay, now I'll discuss the CAP theorem. What CAP theorem says that you can only provide 2 of these. Pick the 2 which you want to provide from this. And depending upon that, you pick the database what you want to pick here. Now I'll have a separate talk. Next talk will be going in much more detail than what I'm talking right now here. But what you're trying to say is that RDBMS you use, or you use Cassandra on the right side. Now you may say that, hey, how am I going to process the data? I want to become eventually consistent, but I still need ACID transactions. You can do that. Depending upon the use case. That was the question asked last time also. So the use case is, I want response time of less than 1 second. Yep. But it does not say the use case is to insert the data. Use case is to get the response time fast. How are you going to do that? whenever you insert something in your transactional database, you raw event source that transaction. When you raw event source that transaction, you can use AWS Lambda, or you can use other technology which are coming in to really put in the scripts to really monitor one table, transaction table, get the data from there, and send that data through Spark to Cassandra database. Now the data is highly available. That's the key part which we are trying to say here. And that's going to give you bank design for performance. And that is really the key. Like you're designing this system for performance. You're not just doing for something. To do that, you want to first look at what's the business problem which you're trying to solve. Your queries must be lightning fast. Lightning fast means really fast service you have to provide. That means it should return really in less than sub-second response time to provide this service. So let's look at a Krill video example here, what I'm saying in this case, where we can watch movies, people can upload their movies, and and people can rate them at the end. So what you do is that you create a conceptual model saying that video appears, video features many actors, actor appears in many videos. You have your own domain model, something similar to that you come up with. You create the purpose for that, how the user is going to use the system. Based on how they're going to use the system, you create the tables accordingly, which are lightning fast. How our table structure looks like, how our query looks like currently, it's like this. Exactly like this. It's a spaghetti. Somebody is using somebody else's table and joining it and trying to use that. It's not going to guarantee you this response time which we are looking for. So what you need to do is you need to create an abstraction layer. When you build an abstraction layer, it's going to provide you much better response time for your linkage. So you create these relationship keys, number one. Number two, you provide application flow. What that means that user logs into the site, they want to get the most recent videos, they want to get the videos which are uploaded by the known user ID for the first few videos which they have loaded. That's it. Based on this model, they come up with the mapping conceptual logical design, which basically gives you something called Chibotko diagram, which basically does create videos by user, videos by user, comments by user. All these things are coming in. That means you're querying really fast. That's the main thing which you're providing here. Otherwise, your queries won't be really fast. That's the key part which is available here. So you may ask a question that, hey, is duplicate data fine? Yes, duplicate data is perfectly fine in this situation, because what happens is that what you're really solving is the response time. So instead of doing a query and doing a join between these two tables, you want to create a flattened data to solve the same problem. So the other problem which we have is something called security the trust boundaries. So trust, what do you mean by trust boundaries? Trust boundaries means that if you see this France and Germany, World War I took place. After World War I took place, France came in and they built this particular boundary, very strong fortified boundary. But they did not took care of the weak fortification. So what happened? Germany in World War II, they came from Belgium, and they had no secure lines there. That's the exact same thing what happens with our applications also. When we are building our application, here, it's very secure. Using it is one rogue app which directly calling our backend service, which is an integration service which we have built in. That's the app which is causing the problem. That's one of the challenges, we all have it. So we should, as part of our project, we should always look for our integration points. Are they secure or not? Are all our integration points are secure? So this is going to really help us drive our processes. That comes a stride model where you want to diagram what it is, identify what kind of threats which are coming in, and try to mitigate those threats. Those are the 4 steps which are there. To do that, what you can do is you can use threat modeling tool. And I'll put a reference, probably won't have time to go over this, but I'll put a reference as part of the slide deck which I'm going to send. What you can do is you can build the application and find out for the web app, when it's calling directly this trading app, you can find out that data flow sniffing can be done. Somebody can sniff this data. It's telling it to us. You can say, oh, this is mitigated because now we have put in HTTPS connection. You know, you can get this diagram and play with this. Not only that, you can play also. There is something called elevation of privilege game. So you can play this game while creating that diagram as part of your team itself. And it has 52 cards for sniffing, and other cards are there to identify the problems which could be there in the system. And you can play with that. And that's where it's going to really help. Okay, so next we'll look at briefly the Spark. I think I talked about this. The important thing in Spark is when I'm running the job, it tells me how much time does it took to finish that. So what it means, it's going to start the processing here. Where is it taking most amount of time? It gives us a UI to basically predict, and there's something called resilience data graph, RDD is there, model which comes in, which really helps us understand what might be wrong with this particular data set for us. So if you see this, this is the whole line, whole line for map reducing. So when I'm doing a text file, I read it from a text file, I split it with a comma separated, and I'm separating the words and counting them and collecting them. So the whole operation is like a simple operation which we need to do now. And when we do that, it has 3 stages, 2 stages, stage 2 and stage 3 showing here. So you read it from the text file, you map, flat map, and reduce that. So what it means that if something goes wrong in the map operation, you don't have to start from scratch. That's the beauty about this. So when you're processing complex parallel operations, you can just start from here, because only this went back. You can come back to this state and start from here. So that's the beauty about this particular map as a whole. That makes it fault tolerant, because now you're fault tolerant in resolving this particular problem. So what it means, if you use Spark, then what can happen is, let me see if it's working. If yes, then I can show it right now. So if I run this sample queries, so this is the Spark, I'm going to run the Spark here. So I'm running the Spark queries, so this is a Spark SQL I'm going to run. It's going to go in and run and find out from the database the mean values and return me those values. So it's going to do the DAG comparison and return me these values to me behind the scene. And currently it's running, it may take a little bit more time. But the same process is being applied when we are doing processing for multiple stream of operations which are being given to us. And let me just show you, the same thing is used by Uber. So if I want to show you that, this is the heat map of the Uber, where when in the morning, when the New York is showing, everybody's coming in the morning, all the cars are coming in, and in the evening, all the cars are going down. So you can find out where you want to place your cars. You can predict where people will be asking for more cars, and basically predict what's going to happen from the analytics perspective. You can do that. So that's where the Lambda architecture comes in, where we are trying to process the data using Kafka. You can send it through the channel because it can partition the data also. So it can partition the data, and you can do the batch processing or near real-time processing. Using data stack also you can use for that. But the whole idea is to alert. At the end, if something goes wrong, you should alert it and make it automated. Alerts should be automated. That's the whole idea behind doing this one. In the end, I'll just talk briefly about the 12-factor apps. 12-factor. So any app which you are building now, you must support 12 factors. Without that, you should not build your application. That means you should have one code base. If you have one application which needs to be deployed, it should have one code base there. You should always configure the files. Don't store all the configuration as part of the server itself. It should be outside the server stored. So that's the kind of thing which is really important. Admin processes must be running. If the server is not up, you should still be able to run the admin processes. That's the key part here. And you should be able to build, release, and run. Those three things you need to do. And you know, there are Netflix and other people, they build something, they write the code, they promote it right away. So the code is promoted the next day. And they do QA in production. That's the kind of thing. That gives you agility and fast response time to the market and how you deal with this. So well, we talked about a lot of things. Serverless architecture is another one which you might want to be interested in looking at, where you only have code present in each one of them. Only when the code executes, then only you are paying for that particular architecture. And open tracing is another one which you might want to look at when you look at this. Well, we had a full pack session. I hope you enjoyed it, and thanks all for coming in. If you have any questions, send me a tweet or ask me later on this session. I'll be available.